Good morning student. Today we are going to discuss about the new chapter group 18th element chemistry second year English medium part 1. Yesterday discuss about the 7th year group elements, that is the last chapter. Remaining another one. Today discuss about the another group of the 18th elements or group 18th elements. It is also known as a noble gases or inert gases. Noble gases or inert gases. Here is the group elements. Group 18 elements are commonly referred as a noble gases. Here is the group 18 elements or 18th group elements are commonly referred as a noble gases or inert gases, which is include those elements are helium, neon, argon, krypton, xenon, radon. Those elements belongs to 18th elements are noble gases or inert gases. It is also called as a 18th group elements by the IUPAC notation. IUPAC notation. The group elements are commonly referred as a noble gases or inert gases, which include helium, neon, argon, krypton, xenon and radon. Those elements belongs to 18th group elements or 8th group elements or 0 group elements or 18th group elements by the IUPAC notation. Those elements also known as a noble gases or 0 group element or inert gases. The general electron configuration of the noble gases are NH2NP6. Here is the commonly electron configuration NH2NP6. The number of s orbitals are considered 2 electron and number of p orbitals consists the 6 electrons. 2 plus 6 is equal to 8 electron. The outermost cells are the full paired electrons. So it is also called as a noble gases, because of those outermost cell fulfilled with the electrons, or exists the octant rule, because of all outermost cell consists the full pair of electrons. So it is also called as the octant rule or stable electron configuration. Except helium, all elements are exist the NH2NP6 electron configuration. It is also called as a octant rule electron configuration. Octant rule electron configuration. Octant means that the 8 electrons consist the outermost cell. So it is also called as a octant rule. Next another one, occurrence. Except radium, in 18th group elements, except radium, all noble gases are present. All noble gases are present at atmosphere 1% of the volume. Here is the occurrence of the 18th group elements or 0 group elements or noble gases. Here the except radon, all noble gases are present in the atmosphere. All noble gases are except radon. All noble gases are present in atmosphere by the 1% of the volume. By the 1% of volume. Next another one, argon is the major constituent in the atmosphere. Here is the in 18th group elements or noble gases, argon is the major constituent. Argon is the major constituent in the atmosphere. Next another one, mineral of radioactive origin contain helium and neon. Helium and neon. Here is the mineral. Which mineral? A radioactive mineral. Here is the radioactive origin contain helium and neon. Radioactive origin contain helium and neon. That is the mineral of radioactive. And next another one, helium and radon. Helium and here is the xenon Xe. Xenon and radon are the rarest elements of this group. In noble gases or 0 group elements, xenon and radon, two elements are the rarest elements. Rarest elements in this group are noble gases. Here is the in zero group elements are noble gases. Here is the radon and xenon. Two elements are the rarest elements in this group. In this group, that is the occurrence of the 80th group elements are noble gases. Here is the noble gases. Noble gases was first isolated by the Bartlett in Colombo University. That is it is isolated. The Bartlett scientists isolated the xenon compound. Xenon compound, that is also known as a xenon react with the fluorine and oxygen. That is also known as a xenon oxides. Next one, xenon fluorides. The first compound is the isolated by the Bartlett in Colombo University. That is the compound is the xenon hexafluoroplatinate. Xenon hexafluoroplatinate. That is the compound. It is compound is isolated by the Bartlett in Colombo University. That is the first scientist name is the Bartlett scientist. That is the discovered the xenon compounds. That is the xenon react with the oxygen and fluorine. That is also known as a xenon compounds. Xenon compounds. The outermost valence shell electron configuration NH2 NP6 except helium. Except helium. Here is the number of s orbital consists the 2 electron and number of p orbital consists the 6 electron. So here is the outermost shell consists the 8 electrons. So it is also called as a octant rule. Octant rule. Due to the presence of outermost shell consists the 8 electrons in the valence shell. So it is also called as a octant rule or stable electron configuration. Or stable electron configuration. Next another one, elements, symbol, atomic number. Next one, electron configuration. The first one, helium. Helium symbol is the He. Atomic number 2, electron configuration 1s2. Next another one, neon. Neon symbol is the Ne. Next one, argon symbol is the Ar. Krypton symbol is the Kr. Next one, xenon symbol is the Xe and radon symbol is the Rn. That is the elements of the zero group elements. Elements of the zero group elements. That is the symbol. Here is the helium atomic number 2. Helium atomic number 2. Here is the electron configuration is the 1s2. That is the outermost shell consists of the 2 electrons. So it is also atomic number is the 2. Next one, neon atomic number 10. Here is the electron configuration 1s2, 2s2, 2p6. Here is the 2 plus 2, 4, 4 plus 6, 10. That is the outermost shell consists of the 8 electron. Outermost shell consists of the 8 electrons. So it is also called as the octant rule or stable electron configuration. Except helium, all noble gases are stable. Due to the presence of the outermost shell consists of the 8 electron. So it is also called as the octant rule. Those elements, electron configuration is the more stable remaining of all groups. Because of those outermost shell consist of the 8 electron or full-filled electrons. Full-filled electron. So it is also called as a stable electron configuration. Next another one, argon. Argon atomic symbol is the Ar. Atomic number 18. Electron configuration 1s2, 2s2, 2p6, 3s2, 3p6. 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12 plus 6, 18. That is the outermost shell consists of the 8 electrons. Next another one, krypton. Krypton symbol is the Kr. Atomic number 36, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6. Here is the 2 plus 2, 4, 4 plus 6, 10, plus 2, 12, plus 6, 18, plus 10, 28, plus 2, 30, plus 6, 36. The outermost shell consists of only 8 electron, 4s2, 4p6. Next another one, xenon atomic number 54. Xenon atomic number 54. Here is the electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6. That is the outermost shell consists of the 5s2, 5p6. Next one, xenon atomic number 86. electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6, 4f14, 5d10, 6s2, 6p6. Here is the outermost cell consists of the 8 electron. Here is the all noble gases. Outermost cell consists of the 6s2, 6p6, 5s2, 5p6, 4s2, 4p6, 3s2, 3p6, 2s2, 2p6. So here is the outermost cell consists of the 8 electron. So it is also called as a stable electron configuration or octant role. That is the electron configuration of the 0 group elements or 18th group elements or noble gases or inert gases. That is the electron configuration of the 0 group elements. Next one, chemical properties of the 18th group elements or noble gases or inert gases. Here is the chemical properties. The first one, those gases are monoatomic nature. Here is the all 0 group elements. Here is the helium, neon, argon, krypton, xenon and radon. Those elements are monoatomic nature. Monoatomic nature and easily soluble in water. Easily soluble in water. That is the first physico-chemical property or chemical properties of the 18th group elements. All noble gases are monoatomic nature and easily soluble in water molecule or easily dissolved in water molecule. All noble gases or 18th group elements are the monoatomic nature. Mono means that the single or one, only one atom. That is also known as a monoatomic nature. Here is the helium, neon, argon, krypton, xenon and radon. Those elements all exist only one atom. That is also known as a monoatomic nature and easily soluble in water molecule. That is also known as a monoatomic nature and easily soluble in water molecule. That is the first property of the 18th group elements. Next, another one, the noble gases are colorless. Noble gases are colorless and odorless and tasteless gases. All noble gases are colorless gases. Does not exist the color. So here is the all noble gases are colorless and odorless and tasteless. Odorless and tasteless, which is very low melting points and boiling points. The all noble gases are exist the low melting points and boiling points and odorless, tasteless and colorless. That is the second property of the 18th group elements are noble gases. The boiling point of the helium. Here is the boiling point of helium is the lowest of any substance. In the all noble gases except helium, remaining all elements are exist the high boiling points. But here is the helium. The boiling point of helium is the lowest of any substance or remaining elements. That is the helium, argon, krypton, xenon and radon. That is the third property of the 0 group elements. They are least reactive. All noble gases are least reactive because of all noble gases. Here is the all noble gases are least reactive because of or due to the presence of the noble gases are except helium. That is also known as a 1s2. Having the completely filled with the NH2 NP6 electron configuration or octant electron configuration. Here is the all noble gases are least reactive or low reactive due to the presence of the all outermost cell or valence cell exist the 8 electron or filled with the electrons. That is also known as a least reactive. All noble gases are the least reactive because of all noble gases are except helium. Here is the helium atomic number 2 except helium 1s2, remaining all elements having the complete filled with the NH2 NP6 electron configuration or NH2 NP6 orbital in their valence cell. That is the chemical properties of the 0 group elements or 18th group elements. Remaining another one, xenon fluorine compounds. xenon fluorine compound. Xenon react with the fluorine to form of the xenon compound. That is the preparation of the xenon fluorine. Xenon fluoride compound, that is the first one. Xenon react or combining or treated with the directly with the fluorine. Here is the xenon react or combining with the directly with the fluorine under experimental condition to form of 3 binary fluorides. 3 binary fluoride, that is also known as the xenon difluoride. Di is the 2. Xenon tetrafluoride, tetra means that the 4. Next third one, xenon hexafluoride, hexa means that the 6. That is the 3 binary compound of the xenon difluoride, xenon tetrafluoride and xenon hexafluoride. That is the 3 binary compound. Here is the preparation of the xenon fluorides. Here is the xenon react or combining with the fluorine, under experimental condition to form of 3 binary compounds like that xenon difluoride, xenon tetrafluoride, xenon hexafluorides. Here is the first one, xenon react or combining with the fluorine at 673 kelvins, 1 bar pressure to form of xenon difluoride. To form of xenon difluoride, di means that the 2 fluorine combining are treated with the xenon compound. That is also known as a first preparation of the xenon difluoride. Xenon react or combining with the fluorine to at 673 Kelvin and 1 bar pressure to form of a xenon difluoride. That is the preparation of the xenon difluoride. Next another one, xenon react or combining with the 2 moles of the fluorine. 2 moles of the fluorine at 1:5 ratio at the 873 kelvins, 1 bar pressure. 1 bar pressure to form of a xenon tetrafluoride. Xenon tetrafluoride. Tetra means that the 4 fluorine atom combining or react with the xenon to form of a xenon tetrafluoride. Here is the preparation of the xenon difluoride. That is the first one, xenon reactor combining with the 2 moles of the fluorine at 1:5 ratio at the 873 kelvins, 1 bar pressure to form of a xenon tetrafluoride. Xenon tetrafluoride, that is the preparation of the xenon tetrafluoride. Remaining last one, xenon reactor combining with the 3 moles of the fluorine at 573 kelvins and 60 to 70 bar pressure, then form of xenon hexafluoride. Hexa means that the 6 fluorine atom combining or react with the xenon at 573 Kelvin and 60 to 70 bar pressure, then form of xenon hexafluoride. Xenon hexafluoride. Next, that is the 3 binary compounds. 3 binary compound, xenon difluoride, xenon tetrafluoride, xenon hexafluoride. Next another one, xenon react or dissolved in the water molecule to form of a xenon oxy compounds. Xenon oxy compound. But here is the xenon tetrafluoride. Tetra means that the 4 atom. 4 fluorine atom react with the xenon to form of a xenon tetrafluoride. Xenon tetrafluoride react with the dioxy difluoride, O2F2. Dioxy difluoride to form of a, here is the 4 fluorine atom react with the another 2 fluorine atom. 4 plus 2, 6. That is also known as a xenon hexafluoride and another one O2 is the form. That is the preparation of the xenon fluoride compound. Xenon fluoride compounds. Here is the xenon react directly with the fluorine under experimental condition to form of a 3 binary compounds like that xenon difluoride, xenon tetrafluoride, xenon hexafluoride. That is the first one, xenon react with the fluorine at 673 Kelvin, 1 bar pressure, then form of xenon difluoride. Xenon difluoride. Next another one, xenon react with the 2 moles of the fluorine at 873 Kelvin and 1 bar pressure, that is the 1:5 ratio, then form of xenon tetrafluoride. Remaining another one, xenon reactor combining with the 3 moles of fluorine at 573 Kelvin and 60 to 7 bar pressure, then form of xenon tetrafluoride. Xenon Tetrafluoride. That is the 3 binary compound of Xenon Difluoride, Xenon Tetrafluoride, Xenon Hexafluoride. Remaining last one, the Xenon Tetrafluoride react with the dioxide difluoride, then form of Xenon Hexafluoride. Hexa means that the 6 fluorine atom, and another one is the form of O2. That is the preparation of the Xenon Fluorides. Good morning, student. Today we are going to discuss about the preparation of the xenon compounds and structure of the xenon compounds. In 8th group elements are noble gases, are inert gases, are 18th group elements. 18th group elements, chemistry 2nd year English medium. Today we are going to discuss about the structure of xenon compounds, and the preparation of the xenon compound. Here is the first preparation. Here is the xenon difluoride. The xenon react with the fluorine in the presence of 673 Kelvin, 1 bar pressure, then form of xenon difluoride. That is the preparation of the xenon difluoride. Di means that the 2 fluorine atom. Xenon combining with the 2 fluorine atom, that is also known as a xenon difluoride. Di means that the 2. A xenon reactor combining with the fluorine at 673 Kelvin, 1 bar pressure, then form of xenon difluoride. Next, another one. Second one, a xenon reactor combining with the 2 moles of fluorine, 1:5 ratio. Here is the 1:5 ratio of xenon and fluorine combining with the 673 Kelvin and 5 bar pressure, then form of xenon tetrafluoride. Tetra means that the 4 fluorine atom. That is also known as a xenon tetrafluoride. Next, another one, xenon react with the 3 moles of the fluorine at 573 Kelvin, 60 to 70 bar pressure, then form of xenon hexafluoride. Hexa means that the 6. That is the preparation of the xenon hexafluoride. Next, another one, xenon difluoride, xenon tetrafluoride, xenon hexafluoride dissolved with the water molecule or reaction with the water molecule or H2O. Here is the first one, xenon difluoride dissolved with the water molecule or soluble in water molecule to form of xenon, and another one hydrogen fluoride. Next one is the oxygen is formed. When xenon difluoride dissolve or soluble in water molecule to form of hydrogen fluoride HF and oxygen and xenon. Next one, xenon tetrafluoride. Xenon tetrafluoride dissolved in water molecule, 12 moles of water molecule, then form of xenon trioxide and hydrogen fluoride. Next one, xenon hexafluoride dissolved in the water molecule to form of xenon trioxide. That is the xenon compounds. Preparation of xenon difluoride, xenon tetrafluoride, xenon hexafluoride, xenon trioxide. That is the preparation of the xenon compound. Next, another one, structure of xenon compound. Here is the first one, xenon difluoride. In xenon difluoride, xenon is the central metal atom. Here is the xenon is the central metal atom. In the xenon central metal atom, the xenon ground state electron configuration NH2, NP6, ND0. That is the ground state electron configuration. That is the xenon ground state electron configuration NH2, NP6, ND0. But xenon is the central metal atom. Xenon first exit state electron configuration NH2, NP5, ND1. Here is the xenon first excited state electron configuration NH2, NP5, ND1. In xenon central metal atom undergo sp3 dehybridization. Here is the central metal atom undergo sp3 dehybridization to form of 5 sp3 hybrid orbital. 5 sp3 hybrid orbital. S orbital 1, p orbital 3, d orbital 1. 3 plus 1 4, 4 1 plus 5. 5 form of sp3 d 5 sp3 hybrid orbital. In central metal atom, xenon undergo sp3 dehybridization to form of 5 sp3 hybrid orbital. In 5 sp3 hybrid orbital, 2 is the bond pair of the fluorine atom, 3 is the lone pair, that is the 3 lone pair, 2 is the bond pair, that is the 5 sp3 hybrid orbital, then form of the linear structure. Here is the xenon bonding with the 2 fluorine atom, then form of 2 sigma bonds with the 2 fluorine atom. Here is the xenon reactor combining with the fluorine to form of 2 sigma bond. Here is the xenon bonding with the 2 fluorine atom to form of 2 sigma bonds with the 2 fluorine atom. Remaining 3 is the lone pairs, 1, 2, 3. 3 is the lone pair atom, 3 is the lone pairs, 2 is the sigma bonds with the 2 fluorine atom, then form of linear structure and undergo sp3 dehybridization. sp3 dehybridization, then form of 5 sp3 hybrid orbital. That is the structure of xenon difluoride. Xenon difluoride. Once again, xenon difluoride, di means that the two fluorine atoms react with the xenon compound, then form of xenon difluoride. In xenon difluoride structure, xenon ground state electron configuration NH2 NP6 ND0. NH2 NP6 ND0. Next, xenon first excited electron configuration NH2 NP5 ND1. One electron jump with the d orbital. That is the first excited electron configuration. In xenon difluoride, xenon is the central atom, undergo sp3 dehybridization, then form of 5 sp3 dihybrid orbital. 5 sp3 dihybrid orbital. In 5 sp3 dihybrid orbitals are 2 is the bond pair electrons of the fluorine atom, remaining 3 is the lone pair atoms to form of a linear structure. In central metal atom, bonding with the 2 fluorine atom, then form of 2 sigma bonds, 1, 2. 2 sigma bond, 3 is the lone pair atom. 3 is the lone pair atom, 1, 2, 3. That is the structure is the form of linear structure. It exists with the 2 sigma bonds with the 2 fluorine atom, 3 is the lone pair atom. That is the xenon difluoride. That is the structure of the xenon difluoride. Next, another one, structure of xenon tetrafluoride. Tetra means that the 4. Xenon tetrafluoride. Here is the xenon react with the 2 fluorine atom. That is the 1:5 ratio. Then it is 673 Kelvin and 5 bar pressure. Then form of xenon tetrafluoride. That is the structure of xenon tetrafluoride. In this xenon tetrafluoride, xenon compound is the central metal atom. Xenon ground state electron configuration NH2 NP6 ND0. NH2 NP6 ND0. Xenon first existed electron configuration NH2 NP5 ND1. But here is the xenon second existed electron configuration NH2 NP4 ND2. NH2 NP4 ND2. In p orbital 2 electron jumping with the d orbital. Then here is the second existed electron configuration consists of the NH2 NP4 ND2. In xenon central metal atom undergo sp3 d2 hybridization. sp3 d2 hybridization, then form of 6 hybrid orbital. 6 hybrid orbital. That is the 6 hybrid orbital is the 2 is the lone pair electrons, 4 is the bond pair electron. That is the 4 fluorine atom bonding with the central metal atom of the xenon. Then form of the square planar structure. Square planar structure. Here is the square planar structure. The central metal atom xenon bonding with the 4 fluorine atom, 1, 2, 3, 4. 4 fluorine atom, then form of 4 sigma bond. Here is the 1, 2, is the 3 and 4. Here is the 1, 2, 3 and 4. That is the 4 bonding of the 4 fluorine atom. That is also known as a bond pairs. Then form of 4 sigma bonds and exist the 2 lone pair electron. Then form of square planar structure. That is the xenon tetrafluoride structure. Once again, in xenon tetrafluoride structure, xenon is the central metal atom. Xenon ground state electron configuration NH2 Np6 Nd0. But xenon second existed electron configuration in xenon tetrafluoride structure. Xenon existed the NH2 Np4 Nd2. So here is the p orbital, 2 electrons jumping with the d orbital. Then here is the xenon tetrafluoride. Xenon is the central metal atom. Central atom, it's undergo sp3d2 hybridization. 1 is the s orbital, p orbital, 3 is the p orbital, 2 is the d orbital, then form of 6 hybrid orbital. Here is the 1 plus 3, 4 plus 2, 6 hybrid orbital. 6 hybrid orbitals are is the 4 is the bond pair electrons of the fluorine atom, that is the form of 4 sigma bonds. Next remaining 2 is the lone pair electrons, then 6 is the hybrid orbital, then form of the square planar structure. That is the exists the 4 sigma bonds, 2 is the lone pair, then form of square planar structure. That is the structure of xenon tetrafluoride. Xenon tetrafluoride. Remaining another one is the xenon react with the fluorine at 573 Kelvin and 60 to 70 bar pressure, then form of xenon hexafluoride. That is the preparation of xenon hexafluoride. But structure of the xenon hexafluoride. In xenon hexafluoride, xenon is the central metal atom. Xenon undergo, here is the xenon second existed electron configuration, NH2, Np3, Nd3. Here is the number of s orbital exists the 2 electron, and number of p orbital exists the 3 electron, and number of d orbital exists the 3 electron. Here is the 2 plus 3, 5, 5 plus 3, 8 electrons. So here is the second existed electron configuration, NH2, Np3, Nd3. Xenon undergo sp3d3 hybridization. sp3d3 hybridization, then form of 7 hybrid orbital. 7 hybrid orbital. 1 is the s orbital, 3 is the p orbital, another 3 is the d orbital. Then form of 7 sp3d orbital. 7 sp3d3 hybrid orbital. In 7 sp3d hybrid orbital, here is the xenon bonding with the 6 fluorine atom. That is the form of 6 sigma bonds with the fluorine atom. That is the 1, 2, 3, 4, 5, 6. In central xenon atom bonding with the 6 fluorine atom, then form of 6 sigma bonds with the 6 fluorine atom of central xenon atom. And consists the 1 is the lone pair atom, then form of pentagonal bipyramidal structure or octahedral structure. Pentagonal bipyramidal structure or octahedral structure. That is the structure of xenon hexafluoride. Hexa means that the 6 fluorine atom react with the xenon atom, then form of xenon hexafluoride structure. That is the structure of xenon hexafluoride. Xenon is the central metal atom. Here is the central metal atom undergo sp3d3 hybridization in third existed electron configuration, then form of 7 sp3d3 hybrid orbital. Consist the 7 is the bond pair electron, that is the form of 6 sigma bonds. 6 sigma bonds with the bonding of the 6 fluorine atom, 1 is the lone pair atom, then form of octahedral structure or pentagonal bipyramidal structure. That is the xenon hexafluoride structure. Remaining another one, xenon trioxide. Xenon trioxide. Next another one, structure of xenon trioxide. Next another one, xenon trioxide. In xenon trioxide, that is also not tri means that the 3. Here is the xenon combining with the oxygen to form of xenon trioxide. Xenon ground state electron configuration NH2, Np6, Nd0 or 5s2, 5p6, 5d0. Here is the xenon ground state electron configuration 5s2, 5p6, 5d0. In xenon compound, that is also known as a xenon trioxide. Xenon is the central metal atom. A xenon third existed electron configuration 5s2, 5p3, 5d3. Here is the xenon third existed electron configuration 5s2, 5p3, 5d3. Here is the 5s2 electron consists the 2 electron. 5p3 electrons are 3 electron. 3 is the lone pair electron. 5d3 also now exists. The 3 is the lone pair electron. In xenon trioxide, xenon is the central metal atom. In third existed electron configuration 5s2, 5p3, 5d3. That is the xenon is the central metal atom. It undergo sp3 hybridization to form a 4sp3 hybrid orbital. 4sp3 hybrid orbital. That is the 3 is the bond pair electron, 1 is the lone pair electron. In central metal atom of the xenon compound, third existed electron configuration 5s2, 5p3. Here is the 3 is the bond pair electron, 1 is the lone pair electron. 4 is the sp3 hybrid orbital. That is also known as a xenon, a reactor bonding with the 3 oxygen atom. That is the form of 3 sigma bond, 3 is the pi band. One of the double bond consists of 1 sigma bond, 1 pi bond. Remaining sigma and pi. Here is the xenon bonding with the 3 oxygen atom to form of 3 sigma bonds. Form of 3 sigma bonds with the 3 oxygen atom. Remaining 3 pi bonds. 3 pi bonds with the 3 oxygen atom. Then form of the pyramidal structure instead of the tetrahedral, because of in xenon central metal atom exists the 3 is the bond pair electron, 1 is the lone pair electron. But here is exists the 1 lone pair electron, then is the 3 is the bond pair electron. Then form of the pyramidal structure. But here is the bond pair electrons are consisted, then form of the tetrahedral structure. But instead of the bond pair, it exists the 1 lone pair electron. Then here is the form of the pyramidal structure. That is also structure of the xenon trioxide. Once again, in xenon trioxide, xenon is the central metal atom. In xenon ground state electron configuration 5s2, 5p6, 5d0. Next one, xenon third existed electron configuration 5s2, 5p3, 5d3. Remaining in xenon is the central metal atom. Xenon undergo third existed electron configuration. Third exist state, it undergo sp3 hybridization, then form of 4sp3 hybrid orbital. 1 is the s orbital, 3 is the p orbital. That is also known as a 4sp3 hybrid orbital. That's are existed xenon central atom bonding with the 3 oxygen atom, then form of 3 sigma bonds with the 3 oxygen atom, 1, 2, 3. Then form of 3 pi bonds with the 3 oxygen atom. 1 is the lone pair, 3 is the bond pair electron. Then form of the pyramidal structure. That is also known as a structure of xenon trioxide. Xenon trioxide. Next oxy compound of Xenon Oxy Tetrafluoride. Xenon Oxy Tetrafluoride. How is the preparation of the Xenon Oxy Tetrafluoride and explaining with the structure of Xenon Oxy Tetrafluoride. That is the question of annual question. Here is the first preparation of the Xenon Oxy Tetrafluoride. It is prepared by the Xenon hexafluoride. Dissolved in the water molecule, Xenon hexafluoride. Dissolved or soluble in water molecule, then form of Xenon Oxy fluoride and hydrogen fluoride. That is the preparation of Xenon Oxy Tetrafluoride. How is the preparation of Xenon Oxy Tetrafluoride? Xenon Oxy Tetrafluoride is prepared by the Xenon hexafluoride compound. Xenon hexafluoride are dissolved or soluble in water molecule, then form of Xenon Oxy Tetrafluoride and hydrogen fluoride. That is the preparation of Xenon Oxy Tetrafluoride. In Xenon Oxy Tetrafluoride, structure of Xenon Oxy Tetrafluoride. In Xenon Oxy Tetrafluoride, xenon is the central metal atom. The xenon second existed electron configuration 5s2, 5p4, 5d2. That is the xenon central metal atom second existed electron configuration 5s2, 5p4, 5d2. So here is the xenon is the central metal atom. In it undergo sp3 d2 hybridization. sp3 d2 hybridization, then form of 6 sp3 d2 hybrid orbital. 6 sp3 d2, 1 is the s orbital, 3 is the p orbital, 2 is the d orbital, 2 plus 3, 5, 5 plus 1, 6. 6 is the sp3 d2 hybrid orbital is formed. In 6 sp3 d hybrid orbitals are exist the 4 is the sigma bonds with the 4 is the sigma bonds forming with the 4 fluorine atom. Remaining xenon central atom bonding with the one oxygen atom, then form of with the one is the bond pair electron, then here is the form of 1 sigma bond, 1 pi bond. That is the xenon central atom bonding with the oxygen atom. Then form of double bond. Double bond consists the 1 sigma, 1 pi. That is the form of 5 sigma bonds. 5 sigma bond, 1 is the lone pair. Totally 6 bond pair electrons. Totally 6 bond pair electron, then form of square pyramidal structure. Square pyramidal structure. Hybridization is sp3d2 hybridization. Thus are existed the 5 sigma bond, 1 is the lone pair, remaining another one is the pi bonds. That is the structure of xenon oxy tetrafluoride. Xenon oxy tetrafluoride. Once again, it is prepared by the xenon hexafluoride, dissolved or soluble in water molecule, then form of xenon oxy tetrafluoride and hydrogen fluoride. In xenon oxy tetrafluoride, xenon is the central metal atom. It second existed electron configuration 5s2, 5p4, 5d2. In xenon oxy tetrafluoride, xenon central metal atom undergo sp3d2 hybridization, then form of 6 sp3d2 hybrid orbital. Then here is the central metal atom of this xenon bonding with the 4 fluorine atom to form of 4 sigma bonds with the 4 fluorine atoms. Remaining central metal atom of the xenon bonding with the 1 oxygen atom, then form of 1 sigma bond, 1 pi bond. That's are totally 5 sigma bond, 1 pi bonds, remaining 1 lone pair, then form of square pyramidal structure. Square pyramidal structure, that is the structure of xenon oxy tetrafluoride. Xenon oxy tetrafluoride. Remaining another one, uses of the noble gases. Uses of noble gases. How is the uses of helium, neon, argon, krypton and xenon? That is the first one. Helium uses of helium. Helium is light or inflammable and it is used filling the balloons which are employed for the metallurgical observation. That is the metallurgical observation. Next another one, helium also used as a cryosurgery or cryogenic agent for the experimental to be carried out of low temperature. Remaining another one, helium also used in a gas cooled nuclear reactors. It is also helium also used in nuclear reactor. Remaining another one, it is used as a diluent for the oxygen. Modern diving operators, because of it very low solubility in blood, that is the helium. Here is the HEA plus O2. That is the mixture of helium plus O2 mixture also used as a diluent for the oxygen. Modern driving opportunities for the, because of it very low temperature or it is very low solubility in the blood. That is the uses of helium. Uses of helium. First one, helium also used in the air bubbles or air balloons to observe the metallurgical observation. Helium also used in cooled of nuclear reactors. Next another one, here is the helium plus O2 mixture also used in diving of the opportunities in the low solubility of the blood. That is also known as a uses of helium. Next another one, neon used. Uses of neon. Uses of neon. Here is the neon is mainly used filling discharges of tubes and fluorescent lamps which are used for the advertising purpose. Advertising purpose. That is the first one. Neon also used filling of the discharge tubes and fluorescent lamps which are also used as a advertising purpose. Advertising purpose. Next, another one. Neon bulbs are used botanical gardens in the greenhouses. That is the uses of neon. Remaining another one, uses of the argon. That is the uses of the neon. Next, remaining another one, uses of argon. Uses of argon. Argon used for the filling of electric bulbs. Electric bulbs. Argon also used for the filling of electric bulbs. Here is the argon also used filling of the argon bulbs. Electric bulbs, sorry. Here is the argon also used in the filling of electric bulbs. Next, another one. It is used as a provide inert atmosphere. It is also used. Argon also used providing of the inert atmosphere during the weldings. During the welding, that is the uses of argon. Next, another one. Argon also used in the laboratory for the handling substances that the air sensitive. That is the uses of argon. Argon also used in the filling of the electrical bulbs. Remaining another one, argon also providing of the inert atmosphere. Next, another one, argon also used in the laboratory for the handling substances that the air suspensive. That is the uses of argon. Next, remaining another one, uses of krypton and xenon. Uses of krypton and xenon. Krypton and xenon also used of argon in the high affinity minor camp lamp. That is the uses of krypton and xenon. Xenon also used instead of the argon in the high affinity minor cap lamp. That is the uses of xenon and krypton. Next, another one, krypton 85. Krypton Kr 85 also used determine the thickness of metal sheets and the plastic sheets. Metal sheets and plastic sheets. Here is the krypton 85 used to determine the thickness of the metal sheets and plastic sheets. Thickness of plastic sheets and metal sheets. That is the uses of the krypton 85. The krypton 85 used for the determining of the thickness of the sheets and remaining another one, fiber sheets. Fiber sheets are plastic sheets. Remaining another one, xenon also used for the filling of the photographic flash tubes. Xenon also used in the photographic flash tubes. That is the uses of xenon and krypton. Remaining last one, radon. Uses of the radon. Radon also used for the radiotherapy of the cancer. Radon also used for the radiotherapy of the cancer. Remaining, it is also used to check defect in the steel coating or steel casting. Here is the radon also used in the check defect in the steel casting. That is the uses of the xenon compound or xenon, argon or inert elements, or uses of the noble gases. Uses of the noble gases of helium, uses of neon, uses of argon and krypton xenon. Remaining last one is the radon. That is the uses of the noble gases. Okay, thank you. 8th group is the closed or over. Next remaining another new chapter, discuss the another class. Okay, thank you.